Hello all. This is my final project presentation for the Emertxe online internship. For my project, I built a well-designed real-time EV dashboard combined with an ADAS warning system, and the whole thing runs on a STM32 microcontroller. Let me walk through what I learned. So, for first, a quick bit about the internship itself. It was an online internship with Emertxe, and it was mainly focused on embedded system, kind of on the automotive electronic side of things. During the internship, I got to learn about embedded C programming, worked with the STM32 Cube IDE, and picked up how to use the HAL drivers, which is nothing but basically the library that lets you talk to the microcontroller hardware without writing super low level code. I also learned how to interface different things like ADC for reading analog sensors, UART for serial communication, GPIO for basic input output, and PWM and timers. And along with that, I got introduced to the whole concept of ADAS, which is nothing but advanced driver assistance system, and how that used in modern EV systems. So why this project, right? The thing is most low cost EV today is EV. Their dashboards are pretty basic and they just show you on some numbers like speed or battery percentage, but there is no real safety intelligence built in that. But if you think about it, a lot of accidents happen just because of drivers' delayed reactions, like they are not noticing an obstacle in a time or not realizing that they are going too fast. So the idea behind the project was, what if we combine both this? Build something that like shows that EV data and also warns the driver when something is unsafe. That is what this project was. So the first part of the system is this dashboard module. This tracks six main things: the vehicle speed, battery level, battery voltage and current, the battery or the motor's temperature in an estimated range. All of this read live through the STM32's ADC channel and some timer logic for the speed calculation. So the second part is the ADAS warning module. So this is the safety side. And there is four features here. Forward collision warning, which check if there is something too close ahead of the vehicle, over speed warning, reverse parking assistant, and an obstacle proximity alert for low speed. Each of this basically compares a sensor reading a safe threshold, and if it crossed, it triggers a buzzer or an LED. That is what the warning system. So this is what the overall architecture is here. So you can see how all the sensors are connected here. So that's the distance sensor and the speed sensor, voltage and current sensor sensing all that and feeding the information into the STM32. The STM32 does all the processing, so sampling through the ADC, running the logic, it compares the value to the thresholds and then it's sent to the dis- output to the display and the buzzer and the LEDs and all the through. So for the hardware, I don't have the hardware. If I have the hardware, these are the hardwares that I need. The STM32 ultrasonic voltage plus the sensors, the temperature sensor and the displays, buzzers and LEDs. Actually, I don't have this hardware side, so I move to the software. For the software, I done all this using the STM32 Cube IDE and CubeMX for configuring the pins and I this is what I used and the embedded C for the logic and all. So now get into how the dashboard actually works. So it's basically four steps. First, sampling the sensor data through the ADC. Second, converting those raw ADC values into actual real world units like volts or degrees, Celsius or percentage like that. Third, calculating the speed. That's done by counting the pulses over a fixed time window. And fourth, refreshing speed the screen every 200 milliseconds. Basically, it refresh again and again in LCD. So this is the logic for the ADAS module. So this is the threshold based, pretty straightforward. Basically, if the distance drop below a safe value, it triggers a warning. The speed goes above the limit, same thing. So it actually shows the warning. That is how the real code I wrote for this. So I can show the C file to you. So C, here is the main C file that I wrote. You can see here what I defined: the threshold, the distance, the speed limit, temperature limit, and down this is the function that actually checks all the three conditions, turn on the buzzer, LEDs and all, and then you just keep reading the sensors again and again, computing the dashboard values, checking for warnings, and sending the data output over again and again in a loop. So this is the C function. So let me actually show you the simulation logic also. See here, this is what it actually the dashboard will be look like if we connect it in the real world system. So here is the dashboard. You can see the speed, battery voltage, current, temperature, all alive, right? So let me run the run auto demo. So just now watch it. If the speed goes above 80, it shows the warning. If the speed, see, listen carefully. If the obstacle comes nearby, also the warning will be here. The buzzer will be on. See this. This is how it will be works. If the temperature climbs also, the safe limit climbs also. Whatever the warnings want to become, it can come. If it crosses the overspeeding, the overspeeding warning will become along with the buzzer on. So yeah, this is basically simulating exactly what would be happen on the real board if all the sensors are connected. This is what the output. Yeah, that's all. So let I go through the result side. So obviously, as a result, the dashboard correctly displayed all the live values. And in terms of what I actually learned, I got more comfortable with STM32, writing embedded C for real-time systems, understanding how ADAS concept actually translate into simple sensor logic, and generally how important simulation is before you even touch the real hardware. That I understand it clearly. And as a conclusion, this project basically shows how one single STM32 microcontroller can combine real world EV monitoring with the basic safety alerts in a pretty low cost setup. So, going forward, this could be expanding things like CAN bus communication to connect to a real vehicle ECU, maybe a camera, lane detection, or GPS based system awareness, and kind of things. So, that's the project. Thank you for this opportunity to build a project like this. Looking forward to that. Thank you.